Okay, this is a good first test. Welcome to the, well, some call it an empire of dirt, some call it a ham workbench. For most of us, it's just the shop. Jim, NO1PC, with a Kenwood TKR 820 UHF repeater on the bench, a SINAD audio meter that's going to tell us if we've got sensitivity peaked up on the receiver. And our goal is to get this repeater, cute little thing, about 20 watts out, matched up with this 3 watt in, 40 watt out, brand new Crescend UHF power amplifier. And so you've heard two things here that you may have caught already: a 20 watt repeater and a 3 watt in amplifier. But the good news is that the PA of this transmitter is able to be turned down to a lower power level and keep it cool and all that. And as part of the rest of the bench, and what we're going to be using here to help get the receiver tuned up, is an ancient Motorola R2001D service monitor set to the receive frequency of our repeater, 448.750. And if you notice this number here, it tells us our sensitivity in millivolts or microvolts and dBm. And presently the receiver, we'll see this on the meter as we go through this, this receiver is about 3/10 of a microvolt, which is not bad, but it's not great. We know it'll do a little bit better. So we're going to do a quick little tune on that. Let me go get set up for that and get right back. Okay, we're back with a little better camera angle here to notice what we're doing. Specific to this radio, but it'll be similar in various others if they don't have a fixed receiver front end tuning. The SINAD is used as a measurement to see one of two specifications of receiver sensitivity, as you may see rated in listed in the equipment manuals. One level is 12 dB SINAD, the other is 20 dB SINAD. The level of quieting, or the reduction of noise coming out of the speaker, as a matter of how quieting it is. And our goal is to see if we can't get this receiver down to about 0.15, 0.16 microvolts for 20 dB SINAD. Some of these will do that, some of them won't. When taking a commercial repeater from, say, the 460 band down to 448, sometimes it's a stretch. If we get 2/10 out of it, maybe even 2.5, that's probably still within spec. We can look that up for this model. But this has always been very impressive. So right now we have a quiet receiver. The squelch is closed. There is a 1/10 of a microvolt going into the receiver input, and as you can see, that's not registering. And if I open the squelch, you might barely be able to tell that there's a 1 kilohertz signal riding in there. Part of this measurement is that we generate a 1 kilohertz audio signal at 3 kilohertz deviation, which is the basis for making the SINAD measurement. So as things get quieter, and the less energy it takes to get to 20 dB SINAD, the more sensitive the receiver is. So I'm going to just go through this here. We'll get enough signal in to open the squelch and get a reading. In fact, let's find out what the 12 and the 20 dB SINAD readings are right now. Okay, trying to get it a little stable. That's about 0.375, maybe 0.38 for 12 dB SINAD, and a whopping horrendous 0.494. Let me close it off again. 0.494 microvolts for 20 dB quieting. That's not very good. That's not going to do our repeater much good. So let me get back to something like minus the 12 dB SINAD range and start some tuning here. And we start with the most immediate part of the front end. And we're getting worse. And right there we get to better than 20 dB SINAD, to a point where we can't tell the meter's wiggling anymore. So we reduce the signal strength, bring it back up to 12. We're at 0.258, so we made a pretty good dent in it already. And we can't get any better than that right here. Let's go to the next stage. And the wrong way on that one. Not quite to not quite to 20 at 0.258. Next stage. We're getting there. We're still at 0.258, 0.26 microvolts, which is maybe spec for this radio. But we'll see. If I get set up, we'll see what adding a preamp to the front end of it does. So it gets so noisy, you close the squelch. So I don't think we're going to get our 0.25 out of it. Out of the box. Just touch everybody up again. And you can hear things that are a little squeaky. Controls are a little tight here. Well, there we are. 0.258 microvolts. Let me quiet that down. That probably masked everything I was saying. I hope not, but you get the idea. It's a lot better watching the meter needle than it is trying to figure this out in your head. 0.258 microvolts minus 118.8 dBm. I think we can do better. Let me see if I can't get a preamp hooked up on here just to show you what value it can give. I'll be right back. Okay. So we've got a preamp hooked up, but well, you'll notice the SINAD meter is showing we're buried much better than 20 dB SINAD receive. And just to let you know, don't get dizzy. Focus, focus. We're at our original 0.258 microvolt setting that the receiver worked on earlier. So what we've done is added a homebrew contained preamp. This is a wonderful little product, a kit you can build or buy from Masters Communications. Focus. It's called a P440 preamp. In kit form, it's $15. Pre-built, I think about $25. And it's about a 14 dB gain preamp. I bundled it in this nice little shielded case here. And I've got a couple others there, but I thought I'd leave the other one raw. We've done a little bit of bench testing with this, tuning it up, just to see what it's, how much fun it was going to be. So, just to show you what it will do in terms of numbers for us, let's get to our back to our 20 dB point, 20 dB SINAD point, and the service monitor is now showing us. Let's see, do I dare zoom in? No, autofocus doesn't like this. 1.144 microvolts or 123.8, minus 123.8. So we've gotten just a little bit more sensitivity for $15 worth of fun build on the bench and experimenting with that. So that's sort of part one of getting a repeater ready to go, is finding out if your radio is going to work. We have a viable system here. Where this the site this repeater is going into has got a receiver pre-selector and preamp system in it already. So we'll see a little bit better sensitivity on that site. Probably, I'm going to say 0.12 microvolts. It's already a very hot receive site, but we've got a PA problem up there. We might have all of 8 watts out, which isn't a great match for for what we'll call the elephant. So we need to boost that up a little bit. Rather than do that with a mobile radio or a non-continuous duty type power amplifier, the Crescend will be our juice source up there. So my next step is I'm going to re-rig here, rewire, do a little tweaking. We can do a little watt meter in and out on this radio as it is in transmit mode, and then see what the Crescend does for us if I tweak it up. We'll be back again. Okay, real quick here, we've got a watt meter hooked up to our transmitter output, and we'll see that this is Indeed a 25, maybe a 30 watt transmitter. We'll call it 20 to be on the safe side. We wouldn't want to be running this continuous duty on the hilltop because it's only got just like many mobiles. Very little heat sink and just not built to handle high power continuous duty. We could pop the top off here, you'd see the construct there, but this is a not a continuous duty, maybe 30% duty cycle radio, and so if we cool it down a little bit and turn it down a little bit, we'll see if we don't do better with a 40 watt continuous duty PA. So let me reconfigure some cables. First thing I'll do here off camera is turn this down to about 2.5 to 4 watts, and then we'll hook up the big amplifier. Okay, we're back. Had to make a power cable. Ubiquitous Anderson power poles. Get that all lugged down onto the chassis. And we are hooked up transmitter output set down to about 3, maybe 4 watts. I'll check that later. And our output to the watt meter. And lo and behold, I'm going to make it a little noisy. And let's see if we can do a little focus here. We got about 42 watts. So in real service we'll probably turn that down. And you can tell the fan changed pitch as we drew less current coming off of it. So there we are. We'll do a couple of transmitter adjustments later on when we get it to the hill, account for cable loss. One thing you'll notice, there's a pile of adapters in this test setup. Not recommended for real life or even for the bench. I just don't have enough of the right cables that aren't tied to something else already. So there we have one of many of a pile of repeaters getting ready to go to hill sites. A brand new amplifier. Interesting swap that made that happen. I think I'll take a break here and give a quick little tour of the shop. Embarrass myself completely.